Hi everyone, here I wanted to go give you a review of test one. Overall, the grade distribution improved after the second attempt. So here you can see that in this case there were um, mostly A's in the class. It was 19 A's for test one after the second attempt, 8 B's, and then it tapers off here. And I'm happy to say that most of the class did pretty well on vectors, which was the most important topic for the test because you're going to see vectors throughout in the next test and the final exam also. So most of the class did pretty well on that. And there are only two questions that more than about half of the students missed. So I won't go over the exact answer, but I'll just describe them a little bit here. So one question that about half of the students missed, about half, is the first one where it says that the car moves at 10 meters per second. So that's a velocity. And it says that the car is initially at 15 meters. So 15 meters, that's a distance which I'll call x. And it says initial, so I'll just call that x sub I. And it's moving towards the right. So here, this might have been something that might have thrown some students off. We're going to assume that to the right means positive x, and to the left is going to mean a negative x. So there's a car, it's moving so here it says actually, let me backtrack here, it says to the left at 10 meters per second. So here the velocity is in this direction, so backwards we're going to assume that that's going to be a negative. And it says that the car is initially 15 meters to the right, so it's going to be over here. So x initial is going to be positive. And we want to find a position after 25 seconds. So we're trying to find, just where it's located later on. So we're trying to find x final. And we're given a time of 25 seconds. So the equation to solve this one is just velocity is equal to final position minus initial position divided by time. The only thing is that you have to include the proper signs. So when you insert the velocity should actually be negative, and the initial position should be positive. And that's really it. And you just want to solve this equation for x final. So I'm just going to solve this using variables. So if I play with the algebra, I will get that x final is going to equal, it should be x initial here, x initial minus vt. So this is actually, once you plug in the signs, I'll let you double check the calculations, but this is actually the form that you want to plug it into. And for the second one, this was a conversion question, and it might be easy to get confused here. So let's see here. So you have 1.5 times 10 to the 3 square miles. And you want to convert that to kilometers squared. So in order to solve for this one, let's see, so we have 1.5 times 10 to the 3 square miles, and we want to convert that to meters. So then you would put a bar. You'll put miles on the bottom here, and then kilometers on top. So again, I'll let you try to get the answer. I'm just going to kind of guide you through here. So let's just say that you have, you'll have to find the conversion yourself between miles and meters. So for example, like 1 mile is going to equal some amount of meters or kilometers, and you'll have to find that. And then you'll just put those numbers here. So whatever the conversion you have, so just put a number here, whatever number you get for kilometers, and whatever number you get here for miles. And the only other thing is that you have to make sure that if there's a power of 2 here, then all of these numbers also have to be raised to a power of 2. And then you can do your conversion. But overall, I think it was the second attempt was a better performance for test one. There might have been some trouble with the lockdown browser. Um, just remember though that make sure that you stay on top of the vectors because you will see that in the upcoming test as well. So if you have any more questions about the test one, please let me know.